Let's talk about inverse trig functions and calculus. This is part 2. This is actually when I get into the calculus part. Now, how do you find the derivative, d dx, of like the arc sine of x? Or how do you find the integral of something like that? That's where calculus makes a big play. So let's see here. Let's say we need to find this, d dx of arc sine of x. Well, that is a transcendental function that we have never done before. So I'm going to go into some of the work that we already have some access to. I know that the arc sine of x is theta. So what I'm trying to find is the d theta dx. So we need d theta dx. Now the way I've got this set up, I want a triangle. As usual, that's the way I function. So here's theta. And I know that the sine of theta is equal to x. So this is x over 1. Might as well fill in the third side. You might be used to this by now, but this side squared plus this side squared is 1 squared. So this is the square root of 1 minus x squared. You can check that with the Pythagorean theorem. So let's find d theta dx. Well, I still don't have it in great shape, but I do know that the sine of theta is equal to x. Okay, that was given. So let's take the derivative of this with respect to x. So let's take d dx of both sides. So d dx of both sides, derivative of sine is cosine. Derivative of theta is d theta dx. This is implicit differentiation. Equals the derivative of x with respect to x, that is 1. So in order to solve for d theta dx, we need to divide by cosine theta. Divide by cosine theta. And so we end up with d theta dx is equal to 1 over the cosine of theta. But that's not written in terms of x. So 1 over the cosine of theta is the secant of theta. Not that you really need that, but 1 over the cosine of theta is 1 over square root of 1 minus x squared. So 1 over square root 1 minus x squared. So there's the derivative. The derivative of arc sine of x is 1 over square root of 1 minus x squared. So there's no trig in the answer, which is kind of interesting. Let's do another couple of these. Now, just to let you know, when you're doing derivatives of arcs, the big three, so to speak, are arc sine, arc tangent, and arc secant. Most texts and most lists actually kind of ignore arc cosine, arc cosecant, and arc cotangent. They are negatives of the other ones, so they're not too much different, but basically there are 3. So this was the first one. The second one is the derivative, d dx, of arc tangent of x. And so I'm going to approach this the same way, except that my triangle is different. The tangent of theta is equal to x. So here's theta, tangent is x, so that's opposite over adjacent. So to get the hypotenuse, I take this squared plus this squared and take the square root. So I get the sum of squares up there. Notice this one was the difference of squares, but the derivative of this. So I know that the tangent of theta is equal to x. So the derivative of both sides, d dx of this and d dx of this one, derivative of tangent is secant squared of theta times d theta dx. Derivative of x is 1. So divide both sides by secant squared, you get d theta dx equals 1 over secant squared of theta, which is the same thing as the cosine squared of theta. All those trig identities come into play here. What is the cosine squared of theta? Well, take a look. Here's your relationship. So this is equal to 1 over 1 plus x squared. Square root squared, 1 squared. So d theta dx is equal to that. Well, theta is arctangent x. So derivative of arctangent is a sum of squares, no square root. Now the third one, of the quote-unquote big three, is the arc secant of x. So again, I'm going to call this guy theta. Put this here. Secant. Secant is hypotenuse. Is hypotenuse over adjacent. Okay? So the secant of theta is x. So hypotenuse over adjacent. So x over 1. There's theta. Well, what's this side? 1 squared plus this squared is x squared. So this is going to be the square root of x squared minus 1. You can check that with the Pythagorean theorem. So there's the opposite side. Now, let's take the derivative. So let's take dx of this, okay? So this secant of theta equals x. That's something I know. That's why I keep going to that. So I've got to take ddx of secant theta, ddx of x. So derivative of secant. Derivative of secant is secant tangent d theta dx. Derivative of x is 1. Solve for d theta dx. We get d theta dx, which is what we were looking for, is equal to 1 divided by secant tangent. Well, if you want to, you can pop this up here and say that it's equal to the cosine of theta over the tangent. Or you could say cosine times cotangent, if you would prefer. So cosine cotangent. Now, I've got to move that out of the road. So the answer, what is the answer? D theta dx is equal to, what's the cosine? Well, here it is, 1 over x. Cotangent is adjacent over opposite. So times 1 over the square root of x squared minus 1. So the answer to this one has the difference of squares led by the variable. It's got a variable outside, okay? So that one looks a lot different than derivative of arcsine, because that one was the difference of squares, but led by a constant, and then arctangent is the sum of squares. So those are the big three, and if you can kind of commit those to memory or think about how they work, that should help with a lot of different problems.